Alrighty, good evening, everybody. Welcome to the midterm review, or I don't even know if you necessarily what you want to call it, the practical review for the Cisco content. I got this little problem here that I've pulled out of a book of mine. For those of you who don't know what it is, it's just basically the VLSM subnetting problem book that's posted in our group chat. But if you look online, you can also find it as well. It's a fairly common book. It's just the IPv4 workbook. So what we're going to do is we're going to look at this particular problem here. We're going to perform the subnetting process, and then we're going to apply this into a packet tracer. That way we can create this sort of demo network as you would, and go over some of the topics that we've discussed so far throughout the year. So with that said, let's get started. So looking at this problem, what we see here is we're given a class C address, which is the 192.168.10.0 network. So if I grab my trusty dusty stylus, let me just switch it to a highlighter. What should we go with? Marker. Go with marker. So we're given this this address here, this 192.168.10.0 network. It's going to be a, like I said, classful C, which means that it was a slash 24. So classful means we're starting out with a slash 24. And we're going to need to break it up into some smaller sections here. So these smaller sections, we're going to need one network here. We're going to need our next network. Largest one will be this 48 host, which is here. That's number 2. We're going to need to then find number 3. The largest after that is going to be this other LAN over here. Then it's going to be this other LAN over here for 4, this WAN, and then this WAN. So we have a total of 6 different networks that we're going to have to break up this Class C address into. So that's actually not too bad, because if we look at the way this is, we'll find out fairly quickly that we have plenty of addresses to work with. So one thing that I always state at the beginning of pretty much everything is that you should always start with the little quote-unquote helper table, as you would. And this helper table is going to make it a lot easier to go through this classless subnetting process, specifically VLSM. So let's go ahead and we'll make that table up. So first things first, let's draw out the table. And we're going to need some space. Okay. First top one is just going to be the binary. We can draw that out. And then the next one is going to be usable hosts. And then we're going to have usable subnets, which really actually we don't necessarily need in this case, since we're addressing it based on the host, not the number of subnets. But we are going to need the subnet mask and the CIDR notation. So we can work with just that. And then let's break this up into some smaller chunks here. So we got 1, 2, 3, 4, 5, 6. We can actually break this up a little bit smaller. No, we can't. Not enough space there. Let's just correct that right now while we have the time. One, two, three, 4. 1, 2, 3. We can make it work. 4. Perfect. Okay, so let's change my color to something else. We'll go with a nice hot red. So we got our binary. We got 1, 2, 4, 8, 16, 32, 64, 128. We only need to worry about the last octet, which is this portion of the address, because this is the only portion that we're going to be doing the host portion with. The rest of it's going to be the network portion, and we're going to be performing a variable length subnet mask to separate this out into separate networks. So now that we have the binary portion put up, we can deal with our usable hosts. And if you recall with usable hosts, basically what we're looking at is a formula of 2 to the n minus 2. And the reason why is because we lose 1 for the network, and we lose another 1 for the broadcast. And if we recall, the network is all zeros for the host portion of the IP address, and the broadcast is all ones for the host portion. So as an example, if we weren't going to adjust this particular address, what would end up happening is in a /24, all ones would basically mean that we have 8 ones. And then we would convert that. That would be our broadcast, and all zeros would be our host portion. But we're going to be making it smaller, so we don't need that. We're not going to do that. So let's just clear that off the screen there, and we'll finish filling this in. So with usable hosts, the one thing that we unfortunately, like I said, have is we have to make sure that we have enough. So the first one is not applicable. We can't do anything with this. Let me just change the color. This nice, wonderful green color. Okay. Next up for our usable hosts is going to be 2, because 2 to the 2 minus 2 is 2. And as I remember saying before, is basically just look up at this, the next portion, right? That's all that's happening, is it's basically 2 less than that. So we go 2, 6, 14, 30, 62, 126, and then last is 254. Because the next one after this would be 256, but obviously we're only dealing with a class C, so that doesn't matter to us. And then if we go the opposite way, now while we're not dealing with the subnet portion, it's still a great practice. Subnets don't have that same part where you have to remove something, so it's just 2 to the n. So if we go in the opposite direction, it's basically just 2, 4, 8, 16, 32, 64, and then we don't have this, and we don't have that, because we can't borrow that many bits out of our host portion, because we need to have at least the minimum, which is 2. And then we're going to deal with our subnet mask. So subnet mask, just remembering that it's basically adding the binary from the other direction. So the first one is 128. Next one is 128 plus 64. So that brings us to 192. And then after that, it becomes 224, 240, 248, and then we got 252. This is going to be a very common one you're going to have to always be dealing with, especially on those point-to-point links. So definitely don't want to forget that one. And then the last bit, not applicable, not applicable. And then this, we take it out, it's going to be /25 because we're borrowing an extra, /26, /27, /28, /29, /30, and you can't borrow that, and you can't borrow that. Okay, so this is for usable. It's not even necessarily usable. So 2 to the n is for subnets, and this upper formula here is for hosts, but specifically it's for usable hosts, because remember, it's usable. It's 2 to the n minus 2 because we're losing 1 to the network and we're losing 1 to the broadcast. So now that we got that all out of the way again, let's just start working down here. So it says specifically that we're looking to start from the largest group to the smallest. So we've kind of already numbered these off. We have 1, 2, 3, 4. And actually, let me just put some lines here so it makes it roughly clean. By all means, I'm definitely not a clean in the handwriting department, but 1, 2, 3, 4, 5, and 6. Perfect. 1, 2, 3, 4, 5, 6. So let's just cross that like that. So in this, the first one is going to require 115 hosts. The next biggest one, which we already checked off, which number 2, is going to be 48. The next one after that is going to be 23. Next one after that is 12. Next one after that is our first WAN link, which is number 5. So we need 2 because it's point to point, right? 1 for here and 1 for there. Similarly, we need 1 for here and 1 for there. So we need 2. Okay. Now, what this means to us, though, in the grand scheme of things, is obviously we can't give it exactly 115. So we need to work up to the next available usable host. So if we need 115, it means we're going to need to only give out 1 bit. So instead of it being a /24, we can push it over and we can make it a /25. So that means 1 bit is being borrowed. So we end up with 2 subnets in the end. One subnet is starting at 0, and the other subnet is starting at 128. Because that's what our magic number is. Our magic number is basically whatever the bit position is for that subnet. So we're borrowing 120. We're going to give it 126. Or if you want to look at the non-usable, it'll be 128. This next one here, 48. What are we borrowing in the end? So we look at the chart. We bring it to the next available portion that it can fit into. And that's going to be 62. Let me take off the circle there. So that's 126. And this is going to be 62 we're providing. For 23, we go up to our chart we made. We got 30. Next one is 12. We go up to our chart we made. It's going to be 14. And then the 2s, we go up to the chart we made. Lucky duck we are. We got the 2 usable hosts. So technically it's 4, but because we're looking at usable hosts, we can do it that way. I know in the past I did it the other way where I did 128, 64, 32, 16, and then 4 and 4. but some people did mention that it was a bit confusing that way. So I just, I'll keep it to the usable hosts. So that's what we're going to end up in the end on each of these. We're going to end up with 126, 62, 30, 14, 2, and 2. And if we break out our calculator and we give that a little whirl, what we end up with is... Let's just see. So if we add up our requirements, we require 202. However, if we add up our place that we're divvying out, 30, 14, 2, 2. We're giving out 236 usable. And we can also add on to that an additional 12 because of the network and broadcast that we're sort of not including in our calculations since it's already there. So 2 for each network, so that's 6. So 2 plus 12, yeah, 248. So we're almost utilizing our entire our range that we were given that Class C, but we still have plenty of room to start. So with the fact that we're borrowing 1 bit, our first one is going to have a, let me just change to a different color. That way it's a little bit, stands out a little bit more. Let's go back to our trusty dusty red. So our first one is going to end up as a /25, not a /26. 25 because we're borrowing 1 bit. Our next one is going to end up at a /26. The next one after that, which is 30, is going to end up as a /27. Next one after that is going to be a /28. It was kind of luck. It normally doesn't happen necessarily this exact perfect way. Next one after this is going to be a /. By the way, these are slashes. They're not they're not ones. This is going to be a /30, and this is going to be a /30. And then what we're going to end up doing is we can now calculate out our subnet mask, at least the last octet, because we know all the first ones are going to be the same. So this one's going to have a subnet mask that ends in 128. This one's going to have a subnet mask that ends in 192. This one's going to have a subnet mask that ends in 224. This one's going to have a subnet mask that ends in 240. And this one's going to have a subnet mask that ends in 252. Like I said, that 252 is going to be your popular one for all them WAN links. Okay. So next up, we need to actually write out what the addresses are. So, like I said before at the beginning, when we deal with the first one, we have a full class, full sub, C. So the first one, we end up with a network that starts at 0 and a network that starts at 128. So we're breaking it up into 2. So our first one is going to, and I'm going to write this into an Excel sheet afterwards in a second. Our next one is going to be a .0. It's going to have the range to 127. So that means our next network is going to start at 128. And it is going to go to, let's see, it's a /26. Our magic number is 64. Well, what's 128 and 64 is 192. So this network then gets broken up from 128, and then it becomes a 128, and then instead of it being two things, it becomes a 192. So now it's two networks from that. So this goes to 192. Or I guess technically 191, since that's where the next network starts. This next one is a /27. So we go over to /27. We go up to the top. Our magic number is 32. So this next, we break up our 192 network, and then we end up having a 192. And the next network starts at 224. So kind of lucky, actually, the way our network's breaking up. So 192 to 223. And then we have our next one here, which is a /28. So the /28 breaks up this 224 network into two pieces, so 224 and 224. And the next one after 224 will be 240, because it ends up, like I said, just being lucky that it's a 25 to a 26 to a 27 to a 28. So we have a 224 to 239. And then what ends up happening next is we can go ahead and break up this last one into some smaller chunks. So this one's going to be a little bit different. So our magic number is now going to be 4 instead of continuing on with these small bits. So it goes to 40 to 44 to 48 to 52, and the next one would be into the new space, which is 256, but we never actually would need that. So what ends up happening here is this becomes 240 to 243, and this one here is 244 to 247. All right. Easy enough. So let's just bring over my Excel spreadsheet so we can write out this stuff here a little bit differently. So when we're looking at our information we have here, we have first our first network. So our first network we have, and we'll call this router 1, and this is router 2, and this is router 3, and this is switch 1, and this is switch 2. And for the sake of testing, we'll have PC1 over here and PC2 over here. So what we're going to do now is we have our network 1, R1, and it's, I believe we're going to be ending up using gigabit interfaces. We're not going to use the serial just because that wasn't actually used yet in the course. So network 1 has R1, has one interface facing outward that has 115 addresses. It's going to have the first IP. So the first IP for this was 192.168. Which address was 6810? Okay. 1910 and .0. And it has a subnet mask of 128. So that's the network. However, let me just shift that way. 10.1. So that's the IP we're going to be. So IP subnet mask. Okay. So that's all we have facing on network 1. Now we can move on to network 2. So network 2, which was our second largest, was coming off of R3. So we got R3 here. And we'll say that this is going to be its first interface. These numbers may not necessarily align. I have to see what the actual switches will be. This one starts at 128. Our first IP address that we're going to be providing to the router is 192.168.10.129. And this has a subnet mask of 192. We're going to be setting up our switch, and this is going to be VLAN 1. It's going to have the next available IP address. Wrong box. 192.168.10.130. Same for that. And this network has PC2 underneath it. FA 130. Now, one extra bit of information we're going to need to get these out of the network is we are going to need a default gateway. Because in order to have PC1 be able to ping PC2, it has to actually go to the router, and then it has to come down. In order for that to happen, when we perform our ICMP, it's going to look and see that this PC2 is an entirely different network, and then it's going to look for this default gateway to forward the package to, and then R3 is going to take care of that for us. So default gateway, and I'll only label that for the ones that require it. So for this one here, the default gateway is going to be the IP address of the interface that's on our router. Okay, let's label that PC2. So that finishes off that network. Now let's move on to network 3. Network 3, we just have R2 facing it. And on R2, let's put that for there like that. And this network is going to be, where do we start? 192. Okay, so 192.168.10.193. 224. Okay. Now this one, we don't have any devices underneath it. We can always add a PC in there afterwards if we want, but for the time being, we're just going to continue with the way this is. Network 4. So network 4 is the one that's off of the R3. So we'll put R3 on there again, but this time we're going to use the second interface. And this one is 192.168.10, and I believe we were at, let's see, 224. Perfect. .224. So we got 192.168.10.225. and then our, oh, missed it, 255.240. Fantastic. Okay. And what we're going to have to do next, however, though, is we got to do our switch this time. Oh, let's label our switch number on this last one, switch 2, because this one is switch 1. And this is VLAN 1 interface we're going to be creating. 192.168.10.226. That's what I said, right? 225. Yes, 226. 240, and we need to set our default gateway because it needs to be able to get out traffic. And then what we're going to do is we're going to configure our PC1 FA0/0. It may be 0/1. I don't recall what the interface is called on the PCs, but it's whatever the interface is. This one is, oh, wrong box we're in. 168.10.227. Okay, but we got to configure our default gateway. Remember, the default gateway is the way out of the network. So that's going to be this interface here on the router. And then we got our network 5 is going to be connected between R3 and R2. So R2 and R3, what do we got? So R3 has used that. So R3, we're going to use the next available one. I'll modify this if we need to. I don't know which interface it's going to end up with, because we're just going to take a router and make sure it has three interfaces. But that would be the next logical interface would be gigabit, the third gigabit on there. So 192.168. 3. Which one is this? .240. Okay, 192.168.10.240. And this is going to be 241. Okay, it's a /30. R2. We only have one thing connected to it so far, so we can use G0/1. And this one is obviously the same network it's going to be on. The only difference is this is going to take 242. Okay, so we got that. And let's go to network 6. Network 6 is going to be R1 and R2. So R2, R1. R1 only has 2 things connected, so no big deal there. We can do G0/1. And like I said, I'm pretty certain that's the interface it is, but we can adjust it if we need to. 192.168.10.244 is the network. And R2, we've used G00, and we've used the second one. So we're going to be whatever its third interface is. Same thing for the network, 192.168.10.244. And the first IP address is going to be assigned to R2. 245. Two, 4, 6. Okay. So that leaves our entire addressing scheme right there that we've just gone through. We got our network 1, network 2, network 3, network 4, network 5, network 6. So now we're going to need to take all this information and then somehow fit it into a packet tracer system. So for those of you who are watching along, if you want, you can go ahead and take a screenshot of this because we'll need it in a few moments. Okay. And pull that off to the side. I'm actually going to pull this off to the side as well so I can look at our topology when we wire this puppy up. And let's go ahead and pull over Cisco. Okay. So we got this wonderful, nice, clean setup. Let's go ahead and we can chuck in the routers that we've been using so far. So we'll just use the 4331. It really doesn't necessarily matter, at least in this example. Though whatever one it asks you for, you should install that specific one. We're going to need 2 switches. We'll go with the safe route of the 2960s. So let's chuck a 2960 there. Chuck a 2960 there. End devices. Grab our PC. Chuck PC there. Chuck PC there. Okay. So that's that. Let's put that there. That there. Okay, and that over there. So far we kind of got a similar pattern going on. Now, one thing we are going to have to do is we're going to have to actually add in possibly some extra interfaces. In this case here, see, it's 0/0/0/0 says 1. Okay, so we can correct that anyways in the document. See, and I was worried I was going to have to add in an extra interface, but they have 3 interfaces. Cool. So what we're going to do is we're going to just edit this. So it's 0/0. This one is 0/0. 0/0. This one's 0/1. This one's 0/0/2. 0/1. 0/0/2. Okay. So now that we've got that all straightened out, let's put that back off to the side again. By the way, if you want to take a new screenshot, there you are. You can take your screenshot, put that off to the side. So what I'm going to end up doing now is we're going to go ahead and connect everything. So while in some cases we've talked about this, and these routers specifically do have auto sensing, so they'll control whether they're in crossover or not crossover. We're going to install the correct cables though. Oh, see, interesting. And actually, it has that other interface, but I think I actually put a module in there. That's probably what's happening. Because I looked at this before and I was like, I didn't think it had the extra thing in there, but I guess I have to chuck a module in it. So let's power it off. Chuck a module in there. Power it back on. Go through this. Okay, so I'm going to go ahead and transfer this next thing. Okay, so we got that one in there. And let's go over here, shut this one off. And we can drag in our interface. Oh, got to turn the device back on again afterwards. Let's see if that helps us be able to connect these things. Interesting. What did that add? Okay, well, clearly that's not going to add what I think it's going to add and what it puts in there for whatever reason. What does this do? Let me just power that back off and back on again and see if that gives us a third interface where we can connect to. If not, I'll throw a switch box in there and we'll just have to deal with whatever the numbering scheme is. So we do need to wait for this wonderful system to power on. So it has... Okay, interesting. Is that what that is? It's just... Or did I forget to power the device back on afterwards? Okay, so that has Uno as 3. Yeah, I think it's just, it does whatever when I just transferred over. It was actually the wrong connection. Okay. Oh, yeah. Yeah, that's me. Okay, so make sure it's the GLC-TE is the module you drag over to it, not the other one, which I was clearly incorrect in. And then afterwards, making sure you power the device back on again. Power the device back on again. Come on. There we go. You can even zoom in, too, if you wanted to see what's going on. Okay, it's powering back up. So good news is obviously we don't have to worry about changing the things. And let's just make sure that's what corrected this entire issue. Perfect. Now, what we are going to do, however, even though there isn't a switch there, we are actually just going to chuck a switch on the ends, and it's not because we're going to use it for anything. We're just putting that there so we can simulate the network connectivity. So let's just chuck that there like that. So we're not configuring this switch. It doesn't exist. And we're not configuring this switch. Doesn't exist. Oh, you can't have two. NA. There we go. This switch over here is our SW1. SW1. This one here is our SW2. This PC is our PC1. Switch this one first. PC2. PC1. Okay. This one is our R3. This one is our R2. This one is our R1. So now we can finally get to the connections. My goodness. So let me just grab my Excel spreadsheet just so I can see which ones are connecting to which ones. So R3 is connecting to R2 over its second to the there. And then this one is R1. And R1 is connecting to R2. So R1 is this interface to R2, which is that interface. And for our R1 network, which has the largest, that's that one to there. We're just going to connect it to the first one, doesn't matter. And R2 is this one is just going to be connected to the first one there. Same thing, doesn't really matter. However, on R3, because R3 is actually sitting in two different networks, PC2 is going to be connected to the G000. So let's put that there. Actually, you know what? Why don't we take advantage of this gigabit speed? Let's do that. So our PC2 is being connected to, what did I say it was? R3000. Let's connect that to gigabit, and let's connect the switch to PC there. See, it's fast Ethernet 0. Oh well. Let's connect that like that. And this one, I like this one. So now we end up with this cute little network. We got our two PCs. You'll actually even see that the PCs are starting their process of bringing the interface online with the switch. That's why we see this this sort of bit going on. Obviously, they won't be able to get out because all the routers are still shut down. But we see that process sort of beginning. And eventually, as you can see, we got our green lights on both sides. So the port has come online. Now, in order to make this network work, obviously, we need to configure up our routers, and we need to configure up our switches. We need to add our IP addresses, all that sort of fun stuff. So let's begin with, I don't know, I would say probably the more important one right now that's actually going to work without any routing, which is R3. So we go into R3. We're going to go into the config, and we're going to exit out. Let me throw my tablet to the side. Okay, we're going to exit out of everything. So we can assume that by accident you've come in here and nothing's configured, which is fine. We go to enable, we go to global configuration mode. We're going to set the host name of this to R3. Just to confirm, yes, that's R3, perfect. All right, so we're going to go ahead now and configure our console. So if we're connecting over the console cable, line con 0, we're going to configure our password of Cisco, and then we're going to tell it we want to use that password. We're going to configure our VTY, and in this case, we're going to make it a little bit different, and we're going to say maybe they asked us to configure, 5 VTYs, so it's 0, 4, because it's 0, 1, 2, 3, 4. Password is Cisco. We'll go to login. They said, hey, let's configure the message of the day. So we go banner MOTD. We put in our delimiting character, remembering that delimiting character can't exist in the message. No unauthorized access. So like that. So now we got a line console configured. We got our line VTY configured. Probably a next, I would say, solid step would be configuring the interfaces, right? Because right now it's not a very good router. It's not doing anything. So let's go ahead and configure those. And if you weren't sure what to configure or where it was, we could simply go into the enable mode and do a show IP interface brief, and we can see here we got our interfaces there. So let's just shift that to the side. 0, 1, 2, and 2. Config T. Okay, so now we got that. We can go into our interface G000, and this is R3. And on R3 G000, we said is going to have an IP address of 192.168.10.129. So we go IP address 192.168.10.129, and we got to put in our subnet mask, which is 255.255.255.192. We can add in our description, because I'm sure we'll probably be asked to do something like that. In this case here, this is facing the 12 hosts. So interface 12 hosts. Okay. No shutdown. Fantastic. Oh, did I mix it up or no? G000 is network 2. I put the wrong one in there. So this is not 12 hosts. This is the 48 host one. Let's see, good catch of mine. So next up, we're going to go to our next interface. Our next interface is going to be R3 facing the 12 host, which is actually network 4. So network 4 was utilizing 0/0/1 IP address 192.168.10.225 255.255.240. Add our description in. Interface, and this was the 12 hosts. No shutdown. Yeah, that's the right one. Okay. And then we can go up now and do our next one, which is G000 IP address 192.168.10. And this is our WAN link. So this one we said had an address of 241. So 241, and a WAN link is point to point, so it only needs 2 addresses, which is why it's a /30, which is 252. Add our description in, WAN to R2. No shutdown. And you'll notice in this case, for instance, the status only changed to up. We actually didn't get the second up. So we got an interface up, but we didn't get our line protocol up. So if we exit out, and actually even before we exit out, we can go ahead and do that no IP domain dash lookup, I think is what it was. Yeah, we can add that command in there. Show IP interface brief. So what we see on that last interface we configured, we've brought the interface online. However, it's still down. And the reason why it's down is because R2 is just being lazy. It's still down. We haven't actually done anything with it yet. However, we can actually go ahead now and we can configure our PC1. So we can go to the desktop. We can go to our IP address configuration. And this is PC1. And on PC1, we did say that it's going to have an address of 192.168. PC1 192.168.10.227. The subnet mask is not a /24 like it wants to default to, so we do need to configure that ourselves to a 240. We are also going to add in our default gateway because we do want it to have the ability to get outside of its own network. So we can add that in there like that. Okay. And we can go to PC2, desktop, IP address. This is going to be a... Oh. I see, in this case here, our table actually, I made a mistake. I didn't actually increment the number for the PC2. I was trying to give it the same number as the switch, which would be incorrect. 10.130.255.255.255.192. And its default gateway is indeed correct at 168.10.129. 131. No, this is C. I'm typing in the switches interface, not the PC, because I made that correction. 10 to 129. Okay, perfect. All right, so that's there. Let me just double check these. 129. Okay. The other one was 225. Let me just double check that over here. What have I done? See, it's a good thing I'm double checking this because I actually made a mistake here as well. Obviously, I would have found that out pretty quickly because it wouldn't have gone through. I'm actually surprised it even let me, to be quite honest, because that's not part of the network. But anyways, we can open up the command prompt here, and we can do a little check and see what's going on. 192.168.10.225. Yeah, see, it goes through. And we can even try actually hitting the other network now and seeing if that actually works, which is 129. That will work as well. And you might ask yourself, okay, well, how is that going to work? Because we don't have any routing in. But the reason why it's working is because PC1 is sending off a ping to the inside interface of R3. And what's effectively happening is it says, well, this isn't part of my network. I'm going to send it to R3. And on R3, if we do a show IP route, you'll see that we have those two interfaces directly connected, as well as we also know about that particular network. So with that being said, we actually should be able to even establish an ICMP to PC2, which would be 192.168.10.131. Let's see. There we go. Perfect. A little bit of that delay. Run it again. You'll see it go successfully. So we kind of have our own little, independent thing here. But we're not technically done because we did say that we were going to set up our management VLAN on switch 1 and switch 2. So let's go ahead and do that. So on switch 1, enable, we're going to go to config T for global configuration, host name, SW1, and we're going to go to our line con 0. We're going to configure our password of Cisco login line VTY04, because we're sort of keeping along that same, they told us maybe 5. That's all it means. It's basically 0 through the max number of connections allowed. Password Cisco, login to tell it to use that credential. Now we can go ahead and configure our message of the day. I'm going to add in our delimiting character on no unauthorized access. No unauthorized access. Perfect. What did we forget? We also forgot to put the service password encryption on the router, so we can go back after in a second. Service password encryption. Enable secret class. Yeah, we forgot to put the class on there too as well. So let's just quickly go do that on R3. Whoopsies. Service password encryption. Enable secret class. And I guess since it's configured, in case something really terrible happens, we should probably do a copy run start. Okay, so let's go back over here and finish what we were doing. So we configured our line console, our line VTY, our banner message of the day, service password encryption, enable secret. So I guess we can go ahead now and configure our VLAN interface. Interface VLAN 1. And we're going to go ahead and add an IP address. So this is switch 1, which we're giving an IP address of 192.168. Which switch? Did I switch to PC2? Oh, that's what I did. Switch to PC2, switch 1 PC1. No, I don't know. I think I'm just forgetting what I'm doing at times. So this is switch 1. So we're going to give this 226.255.255.255.240. No shutdown. So that's going to bring up that management interface. Now, one extra command we can also do is our IP default gateway. And if we don't define that, if we try to ping something outside of our network, it will throw itself in a loop. So let's go ahead and configure that. 192.168.10.225. Okay. And I guess we could also do that other thing again, the no IP domain dash lookup. So we do that. That way, if we accidentally type something stupid here, it's not going to keep searching over and over and over and over again. But let's do our copy run start. Fantastic. Let's move over to this one. Enable config t hostname sw2 line con 0 password cisco login line vty 04 password cisco login banner motd. You should hopefully all by now figure out these basic things. No unauthorized access. We can do our no IP domain dash lookup. We can add our VLAN interface in, so interface VLAN1 IP address 192.168.10.130. Our subnet mask, no shutdown. Wow, that's messed up spelling I got there. No shutdown. We also need to configure our default gateway. IP space default dash gateway 192.168.10.129. So let's see what we got now. Can we ping our other switch? Or can we ping anything on the other network? So this is switch 2. Let's try pinging switch 1. 192.168.10.226. See what happens. You never know. May not work. Maybe we broke something. Ah, there we go. It took a second for it to figure it out, and there we go. So switch 2 can ping switch 1. And let's just check it the other way around. It should be perfectly fine, though. 192.168.10.130. Perfect. So we got that part fine now. Let's go ahead and did I do my copy run start on this switch? I don't remember. Let's just go do it just for the sake. Copy run start. I don't think I did. There we go. So that's now saved. And it's all good to go. All right. So next up, we're going to have to go ahead and configure R2. So let's... Oh, yeah, I guess it would help if I actually powered the equipment on. Is this one powered on? This one is powered on. So while we're waiting, I guess we can actually just deal with R1. So enable config T to get into global configuration mode. Host name R1. And then we can go ahead and deal with our line VTY and console and all that stuff. Line con 0, password, Cisco, login, line VTY, 04, password, Cisco, login, exit, banner, message of the day, no, unauthorized access, service password encryption, enable secret class, no IP domain dash lookup. I think that covers everything from the generic category. So let's go into our interface. So R1 is facing network 1, and it's also facing network 6. So G000, IP address 192.168.10.1. Like that. Description. What was this? 115 hosts. Host network 115. No shutdown. Okay. And it's also, like I said, facing network 6. So let's go ahead and configure that interface, which is G001. So interface G001, IP address 192.168.10.246. And remembering that /30, golden network. So this is the WAN link to R2. No shutdown. And same thing as before. We can go ahead into here. Copy run start. Show IP interface brief. And you'll see that the interface facing the switch has come online. The interface facing the inside network has not, because we didn't turn on the other system yet. So this one over here, we still got to turn on. So now that this is powered up, yeah, no, we're not using this initial configuration. Never, ever, ever in your wildest dreams do you ever want to use that. Hostname R2, line con 0, password cisco, login, line VTY 04, password cisco, login, banner message of the day, no unauthorized access, dollar service, password encryption. We're going to put in our super secret enable secret class password when we want to get to our privilege enabled mode. No IP domain dash lookup. And I think that covers everything for that. Now we can go ahead and configure our interfaces. Now this one's a little bit more in depth, and by in depth it's more like R3, because we actually have 3 interfaces we got to configure. Our WAN to R1, WAN to R3, and our local area network that we're not configuring. So let's go ahead and set this up. So R2 has network 3 interface, which is facing the G000. So let's go in there. IP address 192.168.10.193. And description, I think this is what, 23 networks. This is the Fargo network, eh? Beautiful. Why don't we go ahead and call it that? I guess we could have called the other one the New York network, but whatever, it didn't happen. So this one is Fargo, pretty good show. Network 23 hosts. Fargo. No shutdown. My goodness. All right. So now let's go into our other network. R2's on network 5, which is facing R3. So let's deal with that one, I guess. G001. WAN to R3. G001. WAN to R3. Yes. No shutdown. It's It's always a good thing, like I did with that Excel spreadsheet. It just makes life so much easier going through these things. And the last one on here is going to be G002. So interface G002. IP address 192.168.10.245. Yes, 245. Okay, this is description. WAN to R1. No shutdown. Bam. It's almost like success when you get through all this stuff. Copy, run, start. So now we can see we got in this really pretty network. We got connections, light and green on the Christmas tree. Oh, the world is so happy. Now, if we wanted to, we could check our ability to ping from different points. So obviously R2 can only ping R3 and R1's interfaces because those are the ones it's actually sitting on. If I try to ping the outside interface on R1, we'll find out in a second it's going to fail. If we try to ping the outside interfaces on R3, it'll also fail because there's no networking set up. So let's just go through and try that. So from R2, let's try to ping the R3 link that's facing it. So that would be 192.168. 192.168.10.241. So we'll see that functions. However, if I try to ping 225.25, which is on the inside, it should fail. Because like I said, it has no clue what to do with this network. Unlike when we're dealing with a local network, when it doesn't know what to do, it just forwards it to the default gateway. The router doesn't know what to do because it looks in the routing table and it doesn't see anything. Now, you could hypothetically configure just a default, route. So like on R3 as an example, pretty sure we can configure a static default route that just says, yeah, I really don't want to configure routes for everything. So I can just say, if I don't know where it goes, just shoot it uphill. And that is something that we can actually do. Let me just double check the exact syntax of that. Yeah, okay, so it's exactly what I thought it was. So we can do that, config T. So we can add a default route here, and that's what we're going to do. Now this is something that I don't see being on the test only because it hasn't been actually explained, but still something good to know. And as I sort of discussed before, you can either do a next default hop, or you can do the interface. And if we're doing the interface, I think it should still apply the same way as if it's a default. So let's look at this, my Excel spreadsheet. So R3 is facing R2. So yeah, basically, there we go. So pretty much what it's saying is that if it's not a point-to-point link, that is not a reliable way of specifying the next hop. You need to specify with an IP address. So if I go back here, we should probably do a copy run start. However, what we are going to do is we're going to take a little gander. So now we're going to see that we have this default static route down here, the quad zeros. It's basically just saying this is the default route. If I don't have any other route in my routing table, this is where it's going. That's why it's at the bottom of the list. So it's going to send them that way. So that one we can deal with there. However, R2 really should be see, this is the problem with how we do these routes, because R2 needs to know about R1 on the other end. And then it also needs to know about this, and it needs to know about this. And then R1, since it's all the way up here, we can also do a static route if we wanted to, a static default route that just says forward everything down this way. Or we can manually configure a network for here, here, and here, and this link here. And that's going to kind of clutter up the process. So I think a static, and we'll just do a static, and we'll do it in the other way. Instead of doing the interface, let's do it with the next hop address. So let's go ahead and go into configuration terminal. Okay, and we're going to configure this to be our next hop on this WAN link. And the next hop on this WAN link, this is R1. R1 talks to R2. It's 245. 192.168.10.245. Copy run start. Fantastic. Show IP route. So as you kind of see the difference here, instead of it saying the interface, it's telling you that it's going to be sent out to that specific IP address. It knows the network for that IP address because we have that specific network connected. So that's what we see here. We see the network is this network listed here. We see our interface is holding the IP address at 246, and we see we have this default candidate route of 192.168.10.245. So, last but not least, we need to go to R2, and we need to finish up this, we'll call it a mess. We need to finish up this mess. So we need to configure 3 static routes. Or, we could configure 1 static route and then have 1 default route to cover the networks on R3. That is another approach that we could do. It depends on how you want to do it. We're going to configure them separately, though, because the idea is that in some cases you don't necessarily want to have them separate. Let me just see. R3. Network 1, network. Are they side by side? They are not. Yeah, no, we got to do it separately, unfortunately. I was just trying to see if there was a way we could group them together to tackle the 2 birds with 1 stone. However, it's just not possible with the number of addresses there. So let's just go ahead and deal with it separately. Not a big deal. So off R3, we're going to have to configure 1 for network 2. So 192.168.10.128.192. And the next hop is going to be R3's interface that sits with us. 168.10. 110.2, 168.10.128/25. Next hop 241. Okay, that's fine. And this last one 225. Two 40. Oh. What did I done goof on? Right. It's actually kind of smart. It just said, hey, you entered in something that doesn't make sense. And that's what happened. I entered in the IP address, not the network. Okay, so let's do that. And let's, I guess, test it out. See what happens. So let's go ahead and ping the R2 network. The one that has nothing connected, but we have that one interface. See what happens. May fail a couple, and then it should go through. Yeah, there we go. Perfect. And let's go ahead and ping our one's network. 10.1. I don't like the looks of that. Interesting. Oh, yes, that's right. That actually will not work. And for those of you paying attention, the reason why it's not going to work is because I didn't configure a route on R2 to get to it. So if I go to show IP route here on R2, you'll see I have a static entry for the one network. And I got a static entry for the other network. But I never configured a static entry for this network, which was the whole reason why I had to do it this way. IP route 192.168.10.0. And the next hop is going to be the R1 side of things. 192.168. Copy run start. Okay. It should work now, hopefully. If not, I gotta figure it out. There we go. Took a bit of time for it to build that missing data, and it now works. So our PC1, which is over here, now has the capabilities of pinging, as I take it off, this inside interface off of R1. So I would say that's a pretty good job well done. So what we've done today is we went over our IP addressing. So we did our VLSM of our network. We went through, we configured our 2 switches here, configured 3 routers, configured our PCs on our switches. We went through and we configured our line console password. We configured our VTY, which is used for telnet password. So we have 0 through 4, so it's 5 interfaces. We also did our service password encryption. On the switches, we configured the default gateway, as well as we also configured the message of the day. On the 3 routers and the switches, we also did the no IP domain lookup, so that way we don't get that annoying stuck place where if you type something in the enable mode and get locked out of that for a few seconds or minutes or whatever it is. And then on the routers, we configured all the interfaces, and we configured their VTYs, banner message of the day, Oh yeah, on the switches we also configured the management interface, so we got that set up. Yeah, I think that's pretty much everything that I can think of. So hopefully, for those of you who do watch this, you enjoy it, and hopefully you've learned something from it, or you take something from it and you do well in the practical. Take care and have a good rest of the day.